Okay, so you might have some trouble writing a system of equations for a real life situation. Part of the problem is you really should decide if it's a slope-intercept form situation or a standard form situation. Okay, so I'll start with the slope-intercept form situation. If you're given some sort of initial value, like some amount you're starting with, that's your y-intercept. It's going to go here. And then you're going to be increasing or decreasing by a constant value. That would be your slope here. And your dependent variable is going to depend on the independent variable. Now, if you're looking at a standard form situation, it's when you have like some combination of these values, which are going to give you some sort of known total. Like there's going to be a number here. There should be some known number right there. And same thing here. You'll have some sort of known number. So it'll equal a number here at the end. Well, a slope-intercept form should equal a variable. So let me give you two examples. Here we go. You're running a concession stand at a basketball game. You're selling hot dogs and sodas. Each hot dog costs $1.50, and each soda costs 50 cents. At the end of the night, you made a total of $79.50. You sold a total of 95 hot dogs and sodas combined. So, the first thing I want to ask myself is, do I have some sort of initial value I'm starting off with that I'm increasing or decreasing, from there? And it doesn't really look like it. It's not like I started out with just $1.50 and go up by 50 cents. There's like a combination of these two things that are totaling to $79.50. So that combination tells me I'm looking at a standard form. So that's $1.50 per hot dog plus 50 cents per soda, and it should equal some known value. I know the number here. It's $79.50. So like going back to this, I said that it should equal some sort of number. Well, then that's got to be standard form because I know what it should total. And then the 95 hot dogs and sodas combined is just a simpler equation of a hot dog. The number of hot dogs plus the number of sodas equals 95 items total. And there's lots of combinations of hot dogs and sodas that could get me to 95. So this is a standard form situation. They both equal some known value here, and my variables are over on the other side. Now, let's read this next situation. It says you buy 2 tomato plants and want to know when you can expect them to reach the same height. Plant A is 6 inches when you buy it and grows a ½ inch per week. Plant B is 3 inches when you buy it and grows 1 inch per week. So, I don't know how tall they are. I don't know what they're going to equal, like in terms of the height. And also, like if I look at plant A, I have an initial value. It's 6 inches. I'm starting off with 6 inches. And then I've got a constant value, which is my slope. So here's my slope. It's a ½ inch per week plus the 6 inches I started with. There's my y-intercept. And that should equal the height. The height depends on how many weeks I'm letting this plant grow. So there's an equation for plant A. And plant A is just a name. Like, just because there's an A here doesn't mean there's going to be an A in this equation anywhere. So then plant E is pretty easy. We got 3 inches when you buy it. Okay, there's my y-intercept. I'm starting with 3. And it's growing an inch per week. And then there's my equation. So if you're given a real life situation and you're trying to figure out how to write a systems of equations to represent it, the first thing you really should ask yourself is, okay, am I looking at a slope-intercept form or a standard form? And then sort of look at these models of, if it's slope-intercept form, it's going to be your slope times x plus y-intercept equals the dependent variable. But at standard form, it's going to be some known quantity times x plus some other known quantity times y equals a third known quantity. And if you pick the correct form, then you'll be a lot more successful in writing your equation.